Welcome back, nobody, and today we will be explaining my research papers. Anyway, like as you see, I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 research papers, but however, these four are basically just like the same on the same topic. So we will say like we got 7 or 8 research papers. Anyway, the first one is very speculative. It's like it talks about how to turn an atom X into an atom Y. It's like it's pretty speculative actually. The beam, this is my name actually, and this talks about the Beer conjecture, the Euler sum of powers, and a generalization to the Dirac equations. Anyway, what it says that a to the power of 1 means like one-dimensional object like lines, curves, etc. And basically, from that like geometrical intuition, it says that in order for B to be true, it need no, sorry. Following that mathematical geometric intuition, if we try like to make an argument for the Beer conjecture, and for then we generalize it to Euler sum of powers, and we address the contradiction by saying that there exists an hidden dimension which is time. You're going to read this paper, it's pretty speculative. It will give you a headache, but it's worth it. Now the colors. This is the first one. This is my generalized colors conjecture, colors algorithm. Oh, this is like always a plus. Anyway, so after you sell it, this gives me when I have like x from 1 to 500 and from 1 to 1000, it gives me this rates of conversions, and we see like that 3 is the perfect conversion. After this is k when k is changing, and mostly they are there, so basically the conclusion says that it's not worth it exploring other cases. Now with adaptive collapse algorithm, which is this one, feel free to pause, see it. You get this. So basically, all are there is the stage 1 perfect converse, stage 2 perfect converse, stage 4, which is we got only 1 in the first track here, and the 2 doesn't count because it does count kinda. And here the 2 we got also 100 because it's plus, and this we got the first one, stage 1, and here we got 100% for this number. We haven't got it here, we only got it for one number. How this is an adaptive but still strict algorithm. If I try to make it an adaptive but not a strict algorithm, I think and I strongly believe, and I very cite you to do it. This is all published on Zenodo. The linking is in the description. However, copyright is there, so no plagiarism. Legal action will be taken. Anyway, you can build on this, of course, but don't plagiarize. I know. Anyway, so this is the major advancement, and here we got scroll bars. Basically, we do this if we basically I want to say that if we find 2n have to press in a Goldbach way, a strong Goldbach conjecture, we can find 2n plus 2 as we say it here, and this is the alternative formulation, which is the same thing. And there is critical visualization, divergence gap arguments. So basically, this is the theoretical disaster line where like we will run out of like Goldbach pairs. However, this is the actual prime behavior. So like basically we are safe and we will find like this probably like 99.99% easier reformulations. And the other related one is like here that I say that through this reformulation, when k equals 1, we need k equal 1, and Goldbach like does need k equal 1, and like we get like here the success rate is 37%, and like when we multiply it by 220, we get like at 2030%, which means that the k equals 1 success rate goes down slower, very slower than like the range when goes up. Basically, so the expected disaster rate is 3.2%, let's say, and the actual like rate is 30%. So basically, at 10 times difference, which is like probably more than enough, like to like strengthen the Goldbach, the twin primes conjecture. Here, like I try to like give an existential significance to PV and P. I argue that like if like P equals NP, AI will become more creative. AI will be able to do like complex tasks, just like creative writing, creative proof like Goldbach conjecture or like the B conjecture. AI will be able to compose music, to do this and that, which is like logical. Since like the humans created it, and if it can does what the human does, that means that we are like in a similar foot, in a similar step, and that actually means like since the AI can do it faster, can do it better, more efficiently, that means that AI is going to be miles better than us, which is illogical because the created can't be better than the creator. Like in a general philosophical sense. I also like give some other than philosophical arguments, give like some logical arguments like about logic and about natural proof, like physics, physical arguments also, and cognitive. Like yeah, this like you gotta read the paper. Here the Riemann one is not speculative, but it is like pretty like sus, pretty suspicious, but still it is very interesting. Basically, what I say that the like for the nerds to read it, here you go. You can stop whatever you want. Anyway, basically what I'm saying that the symmetry is the consequence of the structure of the Riemann hypothesis, which means that if the symmetry is true, that means that the structure of the Riemann hypothesis is also true. End of discussion. And here, like enhancement related cryptographics are never published, best quantum security. Here, basically, you need to read the paper. This is also a very interesting paper. Here you go. You can like stop whenever you want. And like let's not forget, I am 16 years old, and I will admit it, I have used AI for like LaTeX, for like experiments, for like writing like advanced like advanced not the core concepts here, but like writing the technical stuff and like the formal way to present it, like every idea. And I basically like I basically like argue it here in PVNP paper. So like no need to like tell me that I am a teacher or not. Anyway, so basically what's this in here what I'm saying is that when the key of encryption is formed, we will not use like a big number or a big prime number. What we will use is we will plug that big prime number into a function, and it will give us a certain like number, and then that will be our key. Like we will round it, of course, to like to we won't round it. We will like truncate it. Like for example, as I say here, like here, where is it? Yeah. So like here is going to be like 512, and here 256 decimal digits, and like here like 128 decimal digits. Yeah, and like our like encryption like formula will be this one. It is very like very not not beautiful at all, but still it was kind of generated by AI because I can't like grasp this much like complexity with cost like to the power of cost like this stuff. I can't grasp everything else except the e to the power of cost key. And anyway, I think here like this is like the reverse one, and I think it's correct. And here like are the benchmarks like at the end. No, not at the end, here I think the benchmarks, the standard TBF, the hybrid TBF, and the strong TBF. Here are the key generation is like 18.5 milliseconds, encrypt, decrypt. Yeah, so like basically this. And we also got like here are like FRSA, standard like RSA, and performance ratio. So in the key generation, we are 18 times faster than RSA. And in encryption, like it says like we are comparable, but like there is like some little like difference. And here RSA is like real RSA is like 5 times faster than us, but still, it is worth it. Anyway, that's it, guys, and thank you for watching. And please, like, go like read my papers from like the like you will find the colored one under the in like the bio, but still go read like these papers from like the start of the video, and love and peace. See ya, guys. Love you.